Then, if I may, I would like to invite the next presenter on stage, will be Pavel Odintsov from FastVPS, who would be talking to us about potential approaches to dealing with modern DDoS attacks. Yes, hello, dear friends. I would like to welcome all those who have come here. I'm very happy that we have plenty of people, and I'm very happy that the topic I'm touching on are of interest to many. I am from the world which is not very much represented here. I represent the hosting provider. Thus, I'd like to start speaking not so much about DDoS attacks, but to speak a little bit about our practice, what we encounter in our day-to-day work. On the graph, you can see the trend of DDoS attacks that were tracked by our equipment, that were monitored by our equipment in the recent 6 months. It's difficult to talk about the trend. We don't see downward or upward trend, but there is a message in the graph that the DDoS attacks are a day-to-day phenomena of that we are to deal with on a day-to-day basis when we are designing new service, when we are thinking about planning our capacity or choosing new equipment, and there is some aspect of those attacks. First graph, you see the total number, but in most cases, when people are talking about DDoS attacks, they are mainly talking about incoming attacks. But there are two sides or two problems. We are encountering both incoming as well as outgoing attacks. You see that the number of outgoing attacks is also quite high. Thus, you have to understand that if you have encountered incoming DDoS attacks, you have to understand that if at some point you would end up being the node from where an outgoing DDoS attack goes out, then obviously you would cause sleepless night for someone else. Thus, it makes you feel more responsible for the data that is going out of your networks. Talking about incoming DDoS attacks, there is a certain trend that is seen by, represented by this graph. Most of those are UDPs, are DNS amplification, SNMP amplification, SHR again, and SSDP service, as well as UPnP. That's quite trivial. TCP attacks are more uniform in most cases. In our experience, that's about 95%. Those are TCP SYN flood. Outgoing attacks have a different trend. I don't know why, but the TCP is more popular. Possibly that is related to the fact that the botnet owners think that spoofing in the networks would be forbidden. Thus, they are using TCP as a stronger tool to fight other networks. Yes. What can we say? Yes, there are plenty of them. Yes, they are dangerous. This graph, unfortunately, it's not so visible. I'd like to let you know that in the peak, the attack reaches 9.5 gigabits per second, about an NPS 4.5 million packets. Yes, that's a powerful attack. Yes, some equipment will be able to withstand this. But this attack shows the trend of the attacks. Those attacks were called flash attacks. That attack reached a 10 gigabit speed and filled up uplink within 25 seconds. What can you do? Even if you have a super strong monitoring system, super detailed, and you have great number of people who are sitting and tracking equipment load, but no single human would be able to do anything within 25 seconds. So what would be the solutions? Those are in two approaches. First is using specialized equipment which would disclose such an attack without engaging humans, and we'll take some measures to mitigate it. There is a list of equipment that I personally have experienced to work with, but in no way does that mean to be conclusive or objective, neither in the list of some preferences, just the equipment that I have experience working with. Of course, there are plenty of companies on the market that are filtering attacks through the cloud, but be it equipment or cloud-based security services, have drawbacks. First of all, it's important, it would be right to mention the cost of hardware to protect yourself from DDoS attacks is not something that any small company, and in many cases even medium companies, can afford, just very large ones. If you compare this with the cost of switches of big GP routers, it's 10 times higher, which is very expensive. On top of this, cloud services are covering part of the problems that they are breaking down the cost of the equipment on a monthly basis, breaking it down by a monthly basis. Those are simpler for businesses, simpler for use, but they have significant drawbacks. For example, they have very much fixed presence points. For example, if you are in Krasnoyarsk, your traffic being routed through Frankfurt or Moscow might be too expensive. In some of the cases, those aspects can be regulated, and some companies might not have the possibility to direct their traffic somewhere. Now, FastNetMon, why is it in the center? Because, first of all, I like it. Secondly, it's something that can be used as a supplement, be it to hardware or the cloud-based services. It's important to understand that majority of cloud-based services for filtration are not turned on an ongoing service, as an ongoing service, but they are being added on with the development of attack. Obviously, someone should generate that order, and that request should be done very quickly, and our solution allows for that. In this case, it also can be used as a trigger to deploy or redirect all of the traffic to filtering equipment, and this approach allows to save the byte capacity not for 100 gigabytes but for 10, and use it only for filtration of specific traffic and then clearing it out.
So what we can do, we can identify any attack which are listed in the most popular ones. It's fragmentation, some others, and many others. And apart from that, I have to say that we can do it very quickly, because when we work, we came across very fast attacks, and in the program we paid very clear attention to this, and it's designed very well in terms of reaction time. The reaction time is more than 1 or 1.5 seconds. If it's captured through this net flow, it's a little more, but it's a hardware limitation of the equipment which generates the net flow. But as soon as it's fixed, identify, we can do something. So not to be, we use the BGP protocol, which can be used for the black hole of our node. I want to say again that we do not block the remote hosts, because depending on the type of the attack, it can be millions, hundreds of millions. That is why trying to add them in the router table, it's not the best idea. You can use the selective black hole, which, for example, has UDP traffic, or selective black hole, which can cut off the specific protocol on the special ports. And of course, the main task is when we work quickly and automatically, we allow to help. It helps us to help to the network engineers. And to identify those attacks, we work with traffic analysis. We have to support any of possible and available ways of getting information about the traffic. And the most popular and widespread protocol is the NetFlow. We support 5th and 9th versions and IPFix version as well, which is known also as NetFlow 10. As an additional wave method, we also use an NetFlow 5, which is not so widespread on routers, but it's widespread apart from that, we have the way of capturing with the mirror ports. And this way is very resource intensive, but it allows to identify those attacks which could not be identified had there been a they were done from the net flow because we have all traffic. We can never look at the payload and see what node is being attacked, what type of attack it is, and generate more specific measures to mitigate this attack. What can we do with this attack? After we identification of attack, we can put the BGP nonce is sent through the XBGP library, which allows, without any additional resources, it allows to send prefix to the host to block it, or we can use BGP and use diversion. You can take it out of the core of the network to the special platform, which is designed to have some can filter this attack more profoundly. We can also cause some kind of custom script and to use the information later about this attack. And we can also put ICL on the switch. And let me tell you more about this method. A lot of people ignore it, but it has a lot of advantages. Most often they are implemented using hardware. It doesn't matter how many rules you have for filtration. You can be sure that this filtration be done through ISIC, and we have no degradation. At the same time, this solution does have some drawbacks. It is not that precise about the packets which we can block. So what platforms they use? We work in telecom, we work in the real world, we work everywhere on all platforms. Some use FreeBSD, some work with Linux. We support Debian family, Red Hat, Ubuntu, and they're all tested. They have packages, and in addition to this, we have appliances. If you don't want to put some soft, you want to, we can start virtual, or you can start our appliance and send out traffic there with the NetFlow, RESTflow, and see that we have a tag. We can get the templates and then go from that. As for the hardware requirements, as I told you, the S-flow analysis, NetFlow analysis, the traffic is has the high indicator of sampling, and that's why we do not overload collector. But if we analyze all traffic and use the mirror ports, we need the whole capacity of equipment. If you want to analyze about 40 gigabit, you need at least one card, and the processor with very high capacity. For this, you will need at least two processor, and these are quite significant serious requirements. But what you'll get from that, you will react and identify attacks quicker. As I told you, we tested the solution on the Miro's ports up to 40 gigabit, and the NetFlow and S-Flow solutions difficult to evaluate which capacity you can analyze because they are different and they're sampled. You can say precisely about 40 gigabytes, but it allows. We can say that the scaling is not limited. If we have enough resources, you can increase the size of the sampling. So the vendors, we work with the real world, with the real equipment, and implementation of NetFlow, S-Flow are different from vendor to vendor. Some we use different ways, different methods. Some use specifics in a platform, so they take it into account. And we can support the Cisco, SRCR, Juniper for several switches from Huawei Extreme 760 series. Of course, Linux with the target NetFlow. It's test environment, but it can be used in some cases. So the attack detection logic. We use mathematical model moving average, and we will calculate with a certain period, 5 seconds, the average speed on the /32 host in our network. And we calculated UDP fragmentation to CPC. And at the moment when the average speed gets to some threshold, which we have in configuration, we either start black hole or start custom list script. And as I told you, we support the main most popular monitor attacks, and in the attack report, you just not get the warning you have been attacked, but you'll get the name of attack. In a number of cases, it simplifies the mitigation, makes it easier, and it simplifies sending requests to special companies which manufacture hardware so that they can provide you with equipment for specific attacks. So this is the example of the attack report. Peak speed, average speed of attack, the protocol, name of attack, and just a number of other, it's a tracking flow. So you will be given all possible information from the nodes of connection, because it's important for the incoming attacks, because from the outcoming attacks, there's always, we use the RC networks, which are given the command to the DOS bot, and it starts the attack, and it allows to identify the command center of trackers and to behead bots, which somehow get into your network. So deploy scheme is very simple. So this is the deploy scheme for the data center, and the main message of the deploy program is to get it closer to the network. Ideally, mirror traffic should be taken from the border of the router, not to allow the traffic to the network where you don't have channel capacity, which cannot process it. So attack visualization is also supported in the graphite system. So this is the example of the attack in the beginning slide, which was developing quickly. What can you do? What can you do? And there is a problem. I several times used this expression, black hole, but this is something which is not that much supported by the main providers. That is why if you represent providers who don't have it, please do it, because modern DOS attacks is that even if you have 4 10 gigabytes ports and 40 gigabytes, 100 gigabytes, it's very easy to make you dysfunctional, because to have attack of a terabyte attack, it's potential, it is possible. And that is why if your operator doesn't support this function, you at least should take care of having an operator who has it. The black hole with the pair, this is, you can say this is mitigation because host is blocked. That's it. And if the client has problems with it and he wants to continue with the service, so it will not work like that. So this additional benefit can be given by a selective BGP black hole, which is provided by several providers and allows to block most popular DOS attacks on amplification to block the UTP protocol. Of course, I cannot avoid speaking about BGP flow spec, which is also known as FT 7555, and it allows to give some rules for blocking traffic. You can just say not just cut off this certain traffic, but you can also block the traffic from the specific node, specific protocol, outcoming from specific network. And if the attack is quite powerful, intensive, it's a real saver. But unfortunately, we don't have a lot of progress in this direction. The companies which provide internet for the end users, household users, please look at the follow the outgoing traffic. So there are attacks from the one data center from 10 gigabytes. It's a real program which we see every day. And if everybody will be attentive to traffic, which is in outgoing, and fix this kind of the peaks and splashes, please do it. Please do it. And I also want to speak about such topic as spreading the information about DOS attack. It just happened that DOS attack is some kind of a sacred knowledge. Information about them, you can go and get some special conferences. It's not good. We all must share the information. If you cannot mitigate some attack, we can share it. Friends, we have DDoS attack and what to do with it. And community at least must be informed. In the best case scenario, they'll help you to deal with it and solve the problem. Thank you. Thank you very much. I think there will be a lot of questions. Here we have at least 2 or 3 companies, apart from Odintsov, who provide services for the DDoS providers, DDoS protection. Yes. So you said about FreeBSD. Do you have port? Yes. Yes, we have it. We will add it to the PR. So send me the number. I'll promote it. Alexey Евстров, Глассвязь. How many people work on this project, and how are you planning to develop it, support it? I mean, how many people do you invest every year? Right now we have 2 people. I do it, and from the network community we have our network administrator, which takes care of deploy, how it's deployed, how it's tuned, adjusted. So right now we want to mitigate as many as possible number of attacks. So this is our priority, but later on we want to mitigate any attacks. And when I say any, I mean attacks on the channel level as UDP, TCP, but not the attacks on the specific applications. So we don't have plans to mitigate in STP flood, DNS flood, but we have plans to mitigate any kinds of attempts to attack TCP stack or ACK flood, to reset sessions. And we would like to help operators to solve the problem with attacks completely. One small question: how long have you been working? The previous version, which was the first one, which was released in June last year, and 2 weeks ago we released the second version with a lot of new features. And I remember there were 27 records in changes. So we are continuously evolving. We are continuously evolving. And of course, there is a huge help from community, because GDPR and Lucent, they support us. And it was done not on my equipment. So these are people who come to me. They say, I have problems with the traffic. My meters went crazy. And the files which they send us, the description of kind of use cases, specific cases, they influenced a lot on developing of this program. And I can say that software really helps with this, with the new ideas. What's the size of the community? How many people actively work in it? Judging by the number of the mailing, it's about like 70 people. Well, let me ask you a question, not as the... I just represent from the industry, and I asked this question many times. And I asked the question to Creator Lab, and the question is if you provide services to a lot of clients, individuals, and you will have some bots which will participate in mass attacks. And in, the question, if would you like to share the information about our traffic format of outcoming attacks so that we can stop attack and to interact with the client. And so the answer, we didn't get it. Apart from hinting that this is commercial information, we are ready to sell it to you. So why would I have an extra headache and protect somebody on the other side of the internet? And your proposal sounds wonderful. So can you please just tell us in detail how you're ready to share the templates of the attacks, and what's your proposal for the eyeball operators who would be able to filter the attacks from their networks? So the attack which come from the domestic networks, so these are the attacks from the compromised computers, so it can be this who just want to overload the channel. It's just a huge traffic, for example, the channel. So some attacks, so not all attacks are slow. The second type of attack, when they use the DNS amplification. So somewhere from outside there is a request with a recursive DNS server client, and it goes out. And the traffic can be not big, 5 megabits, 10 megabits, but it cannot make the difference from a torrent. And on the network levels, one bot can be not 100 megabit, but megabit here, megabit there. And from the viewpoint of it's considered as normal activity.
Yeah. How do you promote the exchange of this information? Maybe there are some ready examples, maybe. The main case or example all related to DNS amplification that can be looked from the port, because DNS amplification comes out of the port 53, which is not normal traffic, as well as port 123 Chargan. I don't know who used it, but it floods it. I'm sorry. Then I forgot the Chargan. Yeah, 19, sorry. Yes, that's also an exotic thing that it's unlikely that a user would be doing. That doesn't look like uploading or downloading pornography. No, it's an identification to what IPs the traffic flows. Are you working on this? Yes, we have this in plans, but I am not confident whether I would have enough time on this. In the plans, we have a service that would allow to analyze based on the backup files that were sent to us, whether this is similar to an attack and whether this is an attack. I understand that there is a representative of DDoS Guard, and I see some representative Labs wants to say. And Curator Labs has very great sympathy of the project. We like very much what is being done, and the sympathy is something that we are very happy to announce it publicly, BT or on Facebook. It's an important project for us that helps cleaning the eco-structure of the internet from the garbage. We have an orthogonal activity which probably well supplements our radar project, allows to take a look at what kind of amplifiers live in autonomous systems and what botnets are living in autonomous system. This is not a description of what is working, what is generating traffic, but about what can generate traffic. And it's quite possible that we can think about some interaction with your product in particular. The information about implementation, its information is accessible for any owner of the orthogonal system. It's enough just to come in and get authorization. We, in our case, I would as a representative of a company, Curator Labs, we very much support the efforts to purify, to clean out the environment from that kind of activity, that kind of garbage. And we also have some work for the community that does not imply any kind of material benefits. Okay, let us ask the colleague to speak. Thank you. Good afternoon, dear colleagues. My name is Dmitry Rut. I'm an engineer of DDoS Guard company. I would like to add that we indeed believe the project of the presenter very interesting. Ourselves, we are using something similar in our own network, but we do believe that this development is very interesting, and we would be ready to engage and support the authors. I would be very happy to accept that help. Thank you very much. We have a question here. Thank you very much for the presentation. And what is that sign on the right? Oh, that's probably what everyone is waiting for, something that I'm between you and the drinks, the tea. A second question, you're talking about the need to monitor the outgoing traffic from your network. And how about not just tracking but actively filtering them out? About ICFO, something that is speaking about the very big utility of that kind of behavior. I would add this in your presentation. We can add that unfortunately we do not have with us our ENOG chair, Andrei Robachevsky, that is promoting Mammer's initiative about the need to behave well in the network. I'd give you a link. There's a wonderful document on the topic that was formulated at ENOG community Odintsov, where FastNetMon is mentioned that one of the measures to protect yourself, as well as many other measures that would allow you to clarify outgoing traffic as well as the incoming. There is the document that aggregates a significant amount of solutions that would allow you to organize mitigation without use of commercial development, open source development, non-for-profit. Any other questions or comments? Well, we are very much ahead of our break time. Thus, I believe we would be able. Okay, then I guess we are going away for a coffee break some 10 minutes earlier now. That way we'll be able to have coffee, get some energy, and overcome the